is the particle theory. Okay, particle theory. And this is quantum physics or modern physics, okay? Is all about quantum and particle theory. So with particle theory, the way I want you to think of it is think about it behaves like a pool ball on like a pool table, okay? And so when you think about a pool ball, it can bounce off the sides and can bounce off sides and be absorbed. Okay? So like think about when the pool ball falls into the net on the sides, that's like it's being absorbed. So particles can be absorbed. When we think about, by definition, a particle is a discrete unit of matter having mass, momentum, and ability to carry charge. And light can behave in those ways. So our main evidence that we see of this is something called the photoelectric effect. Okay, the photoelectric effect. Now, again, this is like a whole other lesson that we're going to just look at the photoelectric effect. So this is just a little introduction. But the photoelectric effect, this is what it is. It's where we have the emission or ejection of electrons from the surface of a metal in response to light. So now in your textbooks, go to page 712. So here you see just little diagrams where you can see there it says photon is like the yellow thing. And then, okay, so here's photon. It emits light. And then usually the target is a metal. And what is released is electrons. So that explains that it's a particle-like property because particles have to collide in order to, like, that electron had to have a collision in order to be shot off, right? Like if we think of our momentum information, okay, so that the photon had to have a particle-like property in order to behave and make a particle-like reaction, okay? So that's, again, that's a whole other lesson that we're going to do. That's the photoelectric effect, which is super cool, okay? So, like I said before, this unit, first we're going to do kind of all of this wave stuff, and then the second part of the unit, we're going to do all of this particle stuff, okay? And remember that on your spectrum, the things that are most wave-like are the lower energy ones, and the things that are most particle-like are the higher energy ones, okay? I think this is going to be fun. I like this unit. Do you like it already? You get to eat chocolate in the next lab we do, so you know. Okay? So when we look at these two models, since there's two models to explain one thing, we call this the wave particle duality. Okay? And this is the big conundrum in physics, is this merging between classical and modern or quantum physics. And this is kind of like Einstein really expanded the particle idea of physics and really like just completely changed quantum physics, okay? And, okay, it's cool stuff, okay? And it's still like physicists are still really wrestling with the idea of particles behave, or like charges like electrons and photons, they behave both like particles and waves. It's fun. Okay, so generally, EMR having a frequency less than visible light is treated as a wave. Just as I was saying, this is talking about the spectrum. If the frequency is low, less than visible light, it's like a wave. If it's greater than visible light, it's treated as a particle. That doesn't mean that they don't have wave and particle-like properties. It just means they behave more like a particle than a wave, or more like a wave than a particle. So for like, you know, when you're doing calculations, those assumptions would be helpful. So again, the first part of this unit, looking at wave. Second part, we're looking at particle. Okay, so now your formulas, the good part. You guys might like these. This one is very important. This is our wave equation for all of wave theory. We did this in Physics 20, right? Yeah, we did lots. So these ones, you've actually all worked with all of these equations before. So it's just a little reminder. Our V is velocity, and generally, always, like unless it's giving like an experiment where you have to find the speed of EMR, you use V from your data sheet, which is 3.0 times 10 to the 8, okay? Some questions might say, like, what's the experimental velocity or something. F is frequency, and that's in hertz, or s to the power of 1. And wavelength is meters. T is 1 over F. F is 1 over T. And since EMR travels at a constant speed as long as it remains in the same medium, we can also use the constant motion velocity equation where we have V equals d over t. Okay? So, let's do an example. If a star explodes 9.85 times 10 to the 26 meters from Earth, how many days would it take the light from this explosion to reach Earth? So remember, light is a type of EMR. So we use our velocity is 3.0 times 10 to the 8 meters per second. I know my distance, and it gave it to me in meters, which is nice. Okay, so first you want to find your time in seconds, and then we'll convert it into days. So if V equals d over t, then t equals d over v. So seconds, you should have 3.28 times 10 to the 18 seconds. So now we, looking at the wrong question there. Okay, so we have 3.283 times 10 to the 18 seconds. Now what I would advise, and in this unit you're going to be doing quite a bit of conversions because you'll have to go like seconds to days or meters into kilometers, and so just be mindful of your unit conversions. So what I would suggest that you would do is use your data sheet with your conversions on it. Do you guys have conversions? Oh yeah, you do. So use this to kind of help you if you get lost. So the way we can set this up is I want to make this hours first. So I want my seconds to cross off. So I'm going to put seconds on the bottom since it's here. So then I think to myself, okay, I want hours as my unit. So then I think, okay, I have 3,600 seconds in every 1 hour. And then I need to get it down to days. So I want to cross off hours. So here I put my hours so that I can cross off that unit. And I want to end up with days. So then I think, okay, there's 24 hours in every 1 day. So then you can go through and type that into your calculator, where you go, really what you will type in is 3.283 times 10 to the 18. Now you could say times by 1 over 360, or you could just go divided by because they're all on the bottom fraction. Okay, either one, you should get the same answer. Okay, so we get 3.80 times 10 to the 13 days. And make sure you're writing out your units as you do it, just so that you keep everything organized.